Hello and welcome to this new video. I will continue my training today trying to solve this old case from Microsoft Excel 1 Championship 2022 from Joseph Palisok, who is also a colleague of mine. So hi Joseph, if you're seeing this video. It's called Maze. It was the case of the first round, so the round of 128. Actually a very nice one. It has basically this maze that needs to be visited by some mice in order to understand where they will be after a certain number of moves, and then it has a very, I would say, difficult level 5, which I hardly think is doable within a 30 minutes allocation. I've solved this manually in the past, and will try to solve this with the formula approach today. So I hope this video will not take too much time to do. Having said that, let's start. So I will first of all import my usual worksheet. So we'll create a copy in order to leverage the setup for the model, and also have my my lambdas if needed. Let's start from level 1. Level 1 says you basically, let's zoom a little bit, says you need to convert basically a cell into a code, and that code will be row times 10 plus column. So I will do right away row of indirect of this times 10 plus column of indirect of this. Yeah, and that's it. So very easy one. Level 2 provides you with a starting cell, and then you try to move up or down depending on the direction you're provided. If that target cell is occupied by water or a wall, you will not move, otherwise you will move. Yeah, and that's it, I would say. Different ways to do this. Probably the quickest one is to copy the maze. So A1 to J10 will be this, and I will put walls and water basically everywhere when needed. So like this, this, and this. Okay, and we have basically our situation in terms of walls and water. I will go straight to example 2, which has this as the starting cell. Then you have the direction. Then you will need some kind of dictionary or table of reference for the different directions. So down, up, right, and left. You will have a row of set and a column of set. So this will be -1, 0, 0 on the rows, and on the columns will be 0, 0, 1, and -1. So this will be my directions, and this will be my there's off. Okay, so I would XLOOKUP this into directions, returning there's directions of sets, and then I will have a target address to come up with, which will be this one. And what I will do to simplify my life is to put walls all around also the maze, so like this. So if I go out of bounds here, I will have the wall. If I go out of bound because I will go one cell left in column A or one cell up in row 1, I will get an error, and I will remain there, of course. So this will be an indirect of maze, and this. If this equals W, then I will keep my current cell, otherwise it will be this, and I will probably throw also an if error, just to say that if I have an error, I will remain there. Okay. I think that's it, because I have A10. I will need to build the data table as usual. Okay, update, and I will copy my results. Okay, and all good, I think. So far, so good. Okay, let's move to level 3 when you have a set of movements, up to 30 movements. Scientist decides to lift internal walls and to cover the water. So essentially for this level you will get a clean 10 times 10 area with nothing restricting the moves inside it. Okay. Well, I will say that simply I will have a maze no wall, which is not northwest. Example 3. Okay, so this will be the transpose of this stuff. This will be this one. Okay, and this will be this. And I will reference made snow wall also here. So I'm saying I will end up in cell J8. No. So I will start J6. Yeah, I need to remove the walls actually, otherwise that's useless. So F8 will be my ending cell, which seems right. So I will just point to that, update, and see if the results make sense for level 3. And actually they do. So we'll move to level 4. Scientists place back the water and internal walls to return the maze to its original position. So basically the same thing, but with the walls. So I will move again the reference to the maze normal, like this. Update, example 4. Update again, J8. Which seems right. So 51, level 4, and that's right. So we are at 640 points, and now I have the monster of level 5. Plenty of time to do this, but I'm not sure I'm going to make it within the 30 minutes allocation, but let's try. So the idea is to basically proceed by keeping the wall on your right. So you start from cell C1, the initial direction is right. You try every time it's possible to move to the right in order to be close to the wall, but of course that's not always possible. So in this case you cannot do that, so you need to proceed in that direction. But you will find some cells in which, for example, you go here, then you're allowed to go up, but you cannot go right, cannot go in the same direction, you cannot go left, you will need to go down. So potentially you will have to check 1, 2, 3 direction. The fourth one, I'm assuming it will be always possible, otherwise it means you will be locked in one position. So yeah, that's basically the idea. And you're asked basically how many moves does it take for the mouse to land on the target cell given a starting cell. So you're basically given C1 as a start one, E8, and you need to answer 27. So what the idea is to build, because I've already done this manually, is to build the exact sequence of possible moves, so the entire path that you will have by going around the wall maze, and then make some logic on that list of cells. So let's build a new worksheet. I think I will need a nice copy of this in order to avoid back and forth in the worksheets. And let's say the start is C1, okay, and the direction is right. So okay, Basically, what I need to check is where is the right, considering that I need this to be dynamic. So if I'm going right, the right is below me. If I'm going up, the right is just right of me, and all the opposite for the other directions. So we'll build a table which has down, up, right, and left. So directions. So right will be my first check. If I'm going down, I said the right should be on the left. For example, look at cell D2. Left as seen from my eyes, so Lorenzo sees right on the left, yes. If I'm going up is right, if I'm going right is down, and if I'm going left is up, okay. That will be the first check. Otherwise, I will check, so here we'll check right, okay, then I will check in front of me, so it will be basically the same of direction. So if I'm going up, I will check up. If I'm going down, okay, so this will be the second check. And then, so for example, here I will check right, okay, it's feasible, right is not feasible, front is not feasible, left is not feasible, and then I will go down. So we'll check, what if I'm here? So here I will check right, and that's feasible, right is feasible, okay, I will check left, okay, and that will be the third check. Check. So if I'm going down, checking left means it's right. If I'm going up, it's left, so it will be possibly the opposite of this. If I'm going right, checking left will be up and then down. Okay, so that's the idea. So that's the idea. What can I do? So first of all, I will XLOOKUP this, so I will call this an XLOOKUP of this, returning this. Okay, so we'll have 3 potential checks to do. I'm interested in seeing which cell is corresponding to each of those, because there I will need to check whether there is a wall or not in that position. So I will do a target address of this, lock rofset will be the XLOOKUP of this into directions, returning directions offset, and I will take the first column, and then I will need the exact same thing, but I will take the last one. Okay, so if I'm in cell C1, checking down means to look at C2 makes sense. Checking right, it means I will check D1, and checking up, it means I will check something which does not exist, because C0 is not reference. Okay, so those will be the checks, those will be the cells to check, and those will be, so this will be the checks, check directions, and so this will be the checks. I will do the indirect of maids and this, so this is an error, but I want to throw an if error also here to say that if I go into an error, it's like going into one wall. Okay, so let's call it chosen direction and target cell. So ifs this is not wall, I will go there. So here, yes. This is not wall, I will go here. So we'll check, right? Check that. Okay, I will need an additional one because Q6. Okay, then I will check this is not wall, I will go here. Otherwise I will need something. In this case I will go right because that is feasible. So that's important because that's the order to check the cells. I will probably add one more row, so baseline, which is not the greatest of the naming convention, but which is basically where I will go in case of a complete turn. So here I will check right, front, left, down. I'm going up, so I will go down, so it's basically the opposite of my direction. So it's up, it will be down, it will be left, and it will be right, which is exactly the direction was missing here. And so in case of true, I will do an X lookup of this into this one, returning this one. Okay. And so yeah, maybe it's easier to do this to be more structured. This will be always valid. The checks will be like this, and the chosen one will be this, and the target cell, I'm going to match this into this, exit match, and I want an index of this row number 1. Okay, so in this case I'm going to D1, which is actually right. My next starting cell will be exactly this. My next direction will be exactly this, and everything is basically the same. So let's see if this works. So now I can go D2, then I will go D3, C3, B3, A3, A2, A3, so there is a complete turn. A4, A5, A6, A7, A8, A9, A10, A9, A8, 7, 6, what? Okay, 5, B5, yes, C5, C6, D6, d7, e7, e8. So apparently is working. I will need to get back to c1. After I don't know how many moves, but g1, h1, g1, g1, so g1, h1, g1. I think in close. f1, f2, e2, d2, d1, c1. d1, c1. Okay, so it's right. So it's working. 20 minutes in. Okay. Because now I have the setup in place. For example, if I look for e8, it will be a simple match here, but because I'm starting from the same cell, okay, so probably -1 to match the example. What if I'm starting from h1? Well, that's that's a problem because h1 is here. So I will somehow, I could put it here, but I'm not sure I will have the direction set up. So maze around setup. What if I create a new sheet from this? Create a copy. Call it level 5. Actually, so example 5. I'm going to XLOOKUP this into this, returning this. Okay, so the start will be here. If I move to, let's say, 71, it's the same thing, 72. Okay. Body direction will be the XLOOKUP of this into those ones, returning the directions. So h1 will be right. The first time I find h1. Okay, and what if I match this here? 0. So 35 -1. So example 1 no, it's clearly not working. We'll need example 5, which is 27. Well, let's try to scale it. So sequence of 30 starting from 71. And I will be playing on, no, sorry, I will be returning this. So this will be the example. Let's see if this is correct. Not sure this will be completely right, and actually it is. So kind of surprised by this outcome, especially come on. I cannot apparently. Okay, so 1000, but I'm struggling. Okay, oh, come on. I probably need to change mouse for sure because I'm having serious problems. Okay, with my mouse. Yeah, that was nice. Honestly, I have a little bit of thinking before approaching this on how to to structure this kind of setup. But yeah, wasn't expecting to complete this within the 30 minutes. To be fairly honest, in competition condition, I will never have done this for sure. And I think also checking the results of the other people in the competition, I'm pretty convinced no one got the 1,000 points, but I will check this to be 100% sure. So yeah, I think this was a nice application to have a dynamic logic to consider where to move in a grid or in a space, depending on some factors and constraints. Hope you enjoyed the video, and we'll see you in the next one. Bye.